In this video, we're going to look at learning objectives 1A and 1B. We will identify individuals and variables in a data set, and then classify variables as being categorical or quantitative, and then we'll identify the units of measure for those that are quantitative. Let's start by defining individuals. Objects described by a set of data. Individuals may be considered to be people, animals, or things. A variable, then, is any characteristic of an individual, and a variable can take different values for different individuals. A categorical variable places an individual into one of several groups or categories, and it cannot be a numerical value. So a good example would be if someone asks you, what is your eye color? You would say blue, brown, hazel, so forth. A quantitative variable, then, is a numerical values. It makes sense to find an average for those. So a good example of something might be someone would say, what is your height? You might say 5 feet 10 inches, 6 feet 2 inches. That data could be taken and crunched together, and an average could be computed. These two vocabulary words seem very basic, but I will tell you they are the fundamental principle of this AP Statistics course. When you read a scenario, you need to know if it's categorical or quantitative, because that will allow you, when we get into things further, to determine what type of test you would do on the data. Here's a newspaper example. They want us to look at various variables that might be related to the newspaper and determine if they are categorical or quantitative. So if we go through, I'm just going to put a C for categorical and a Q for quantitative. So let's go ahead and do this. The sex is male or female. This would be considered categorical because you're giving a word answer. The age would be quantitative. You give a numerical answer. The zip code where you live, be careful. Zip codes are numbers, but would you compute an average zip code? That doesn't really make sense. A zip code in this case is technically a categorical variable. Your favorite television program would be categorical, again, because it's a word answer. Height would be quantitative. Weight would be quantitative. The age of your siblings, where you would say no siblings, teen, or child, in this case you're not giving the actual numerical age, but a word, so this would be categorical. And then are you an adult? You would circle it if it's true. This would be a categorical type of answer. Another example here deals with some data, the numbers 17, 21, 44, and 76. In each scenario, determine if it would be considered quantitative or categorical. If these were the ages in a golf foursome, in that case, if these pieces of data represented an age, it would be quantitative in nature because we could compute an average age. Now, if it was scenario 2, their uniform numbers on a football team, it doesn't really make sense that player 17 and player 21, that we would add them up and take the average. In this case, it would be considered categorical. To further check your understanding, let's look at this. Jake is a car buff who wants to find out more about the vehicles that students at his school drive. He gets permission to go to the student parking lot and record some data. Later, he does some research about each model of car on the internet. Finally, Jake makes a spreadsheet that includes each car's model, year, color, number of cylinders, gas mileage, weight, and whether it has a navigation system or not. The first question here is, who are the individuals in Jake's study? In this case, the individuals are the cars in the student parking lot. Next, what variables did Jake measure? And then identify each as categorical or quantitative. When we take a look at it, they clearly told us the variables up here that Jake measured. So I'm going to jot those down. So the 7 different variables are model, year, color, number of cylinders, gas mileage, nav system, and weight. Now, of these 7 variables, which are categorical and which are quantitative? 3 of these are going to be categorical. So if we look at that, the model of your car is categorical, the color is categorical, and if you have a navigation system or not, you would say yes or no. That's considered categorical. These other ones could all be computing averages from, so year, number of cylinders, your gas mileage, and the car's weight are all quantitative variables. Now, distributions are used quite often in AP statistics. And what they do, it's of a variable, and it tells us what values the actual variable takes and how often it takes these values. So, for example, talking about eye color, you might see a distribution of eye color of students in a class. Maybe it would be a bar graph, and it would show the counts of those with brown eyes, blue eyes, green eyes, and so forth. Now, in this example of residents, we have information about 10 randomly selected U.S. residents from a 2000 census. We have state, number of family members, age, gender, marital status, total income, and travel time to work. The first question here are, who are the individuals in this data set? A good answer for this would say that it's 10 randomly selected U.S. residents from the 2000 census. Part B wants to know what variables are measured, and again, are they categorical or quantitative? And in what units would the quantitative elements be measured in? So on here, there are 3 categorical ones. And those would be state, gender, and marital status. Therefore, the other 4 are quantitative. That would be the number of family members, the age, the total income, and the travel time to work. Now, in what units of measure would these be measured in? A number of family members could be counts. Age might be in years. Income would be in dollars. In travel time here, it looks as though it's probably in minutes. Part C then wants us to describe the individual in the first row. So this particular person from Kentucky has 2 family members, is 61 years old, is a female who's married, makes a total of $21,000 a year, and works 20 minutes from where she lives. So here in this paragraph, I said a 61-year-old female living in Kentucky who's married with 2 members in her family. She drives 20 minutes to work and makes $21,000 in total income. Now, there is a smart and logical way to actually explore data. One of the things you will first do is just examine each variable by itself. So you would look at all of the elements or the rows in your table. And then you can next start by studying relationships among those variables. Once you've looked at the raw data in that format, you will probably start making a graph or a couple of graphs to analyze the data sets. And we will focus on making various graphs in sections 1 and 2. Then we're going to talk in section 3 about adding some numerical summaries. How can we get quantitative data to be summarized so it makes more sense to us? So in the grand scheme of things, this one slide here really covers the entire book, believe it or not. This is all the information you're going to learn about how to do in the book. One of the things we're first going to do is we're going to talk about if you take a sample. We would take a sample of data, we would collect the data from the sample and make sure it's a representative sample. From there, we would then take the data and analyze it. When we analyze it, it's just not tables and graphs, but we might be talking about probabilities. After we have that data, then we can make some inferences about the bigger population in which we are concerned. Because in statistics, what you really want to do is you want to know about a population, but you don't have the time or the resources to ask the entire population. Therefore, you take a sample, you go through this entire cycle in order to make an inference of what we think the population will do. So we will kind of be visiting this entire rotation as we do our learning of the entire book. Now let's wrap up this learning with an activity. This is called hiring discrimination, and here's the scenario. An airline has just finished training 25 pilots. There's 15 male and 10 female to become the new captains. Unfortunately, only 8 captain positions are available right now. The airline managers announced that they will use a lottery to determine which pilots fill the available positions. The name of all 25 pilots will be written on identical slips of paper, which will be placed in a hat, mixed thoroughly, and drawn one at a time until 8 captains have been identified. A day later, managers announced that the results of the lottery. Of the 8 captains chosen, 5 of them were females and the other 3 were males. Some of the men pilots weren't selected, suspected the lottery was not carried out fairly. One of these pilots asked our stats class for advice on whether he should file a grievance against the pilots' union. So how could you go about addressing this issue? Well, we're going to do a simulation, and we don't physically have the cards in front of us, but Imagine you have a deck of playing cards. And so what we're going to do is we're going to separate the playing cards into piles by suit. So in this case, there are 13 diamonds, spades, clubs, and hearts of each of the suits. To simulate this, we want to try to come up with 25 different pilots. Again, we want 15 males and 10 females from our deck of cards. So there's a variety of ways you can do it. One suggestion is this. For the females, we're going to need 13 cards of a suit. So for the ladies, let's use the hearts, the 1 or the ace through the king, which will give us 13 cards. And we would put those in a pile. Now for the guys, we need to represent 15 male pilots. So maybe we'll use some of the black cards for that. So we could go ahead and use all of the clubs, which would be the ace through the king, which is 13. And then how about the 1 and 2 of spades? So we'll have all of those black cards. So if we put all 25 of these cards in one pile and we shuffle them, we could select 8 different cards. Of those 8 cards that show up, we would basically just count how many of those represent the women and how many represent the males. So imagine these are the 8 cards that we picked. If this was the case, we would count that there were 3 females, and we would record in our first trial there were 3 females. We would then put these cards back into the deck, so we have 25, reshuffle, and do this again. The more times we do this simulation, the more accurate we will get to what the true scenario would be. We're going to actually skip doing the simulation since we're in a virtual world, but let's look at the results of a distribution if this was done many, many times. This is actually a graph we're going to talk about later in the chapter. It's called a histogram, and it shows the counts or the frequency of how many times the different outcomes took place. So if we take a look at this, we see that 0 females, 1 female, all the way up to 8 females. Again, in choosing from the 25 cards how many times it happened. There were 8 times that 5 females were picked, 7 times that 4 females were picked, and so forth. So if we look at this, if I actually count up all these values, by the way, there were 33 trials of this experiment. So the question is, what should the guys do? Should they complain about it, or should they just quit being a baby and accept the results? That of the 8 captains picked, 5 of them were females. What do you think? Well, if you look at this graph, you guys, in order to have 5 females in our simulation of 33 trials, it actually happened 8 times. But what if it happened even more than 5 women? What if there's 6, 7, or 8? All of these here represent how many times 5 or more females were actually chosen. So if you count this up, you're going to notice 18 of the 33 trials actually were in favor of the women. That's almost 55% of the time. So I think we all could conclude that the guys need to just quit being a baby and accept the fact that of the 8 positions, 5 of them are held by women. And that's the end of this lesson.